When we're simplifying the root of an exponential expression, we divide the exponent by the index of the radical to figure out what our new exponent will be. However, sometimes the exponent isn't divisible by the index of the radical. For example, suppose we're looking at the square root of x to the fifth, where the index of our radical is 2. 5 is not divisible by 2. So what that means is we're going to still divide, but there's going to be a remainder. The remainder is going to tell us what power of the variable will still remain under the root. For example, here 2 goes into 5 twice with a remainder of 1. Since it goes in there twice, we'll have x squared. Because there's a remainder of 1, we'll have x to the first, still under the square root. So we're still dividing 5 by 2. 5 divided by 2 is 2 with a remainder of 1. Normally people wouldn't write the 1 exponent. This would normally be written as x squared times the square root of x. Let's look at an example with a fourth root. The fourth root of x to the 11th. 11 is not divisible by 4, so we're going to have to think of what the remainder might be. 4 goes into 11 twice with a remainder of 3. Since it goes into 11 twice, we'll have x squared. Since the remainder is 3, we would have x cubed left under the root. And notice the type of root you start with is the type of root you finish with for this problem. So the answer for this one would be x squared times the fourth root of x to the third. Let's take a look at some examples of problems where we're putting this into practice. Our next example, we have the square root of 49x to the third. Let's think of the number and variable parts separately. For 49, the square root of 49, we put 7. Then for the square root of x to the third, we need to think how many times does 2 go into 3? 2 goes into 3 once with a remainder of 1. Since it goes in there once, we have x to the first. Since the remainder is 1, we would have x to the first still left under the square root. And normally we would see this written as 7x square root of x. If we look at a problem like the next one, the cube root of 54x to the 6th, y to the 8th. Let's think of the number part, the x part, and the y part separately, and then we'll put the answers together at the end. For the cube root of 54, 54 is not a perfect cube, but we can split it up into 2 factors so that one of them is something that we can simplify the cube root of. 54 is 27 times 2, and the cube root of 27 is 3. So the numerical part of our answer here would be 3 cube root of 2. When we're focused on the next part of the problem, the cube root of x to the 6th, 3 goes into 6 exactly twice with no remainder. So we would have x squared. To simplify the cube root of y to the 8th, 8's not divisible by 3. So this is where we're going to use that new technique we're talking about, figuring out how many times 3 does go into 8 and what the remainder is. 3 goes into 8 twice with a remainder of 2. So we would have y squared and then the cube root of y squared. To finish now, we take the portions that aren't under the root, the 3, the x squared, and the y squared, and we'll write those together at the front. And we take the parts that are under the root, the cube root of 2, the cube root of y squared, we put those together under 1 cube root. If you would like to try the next problems on your own, pause the video now and resume when you're ready to see the solutions. For the square root of 200y to the 11th, we'll think of the number part and the y part of the problem separately. 200 is not a perfect square, but we can split it up into two parts so that we can simplify the square root of part of it. We can write it as 100 times 2, and the square root of 100 is 10. So the number part of this answer would be 10 square root of 2. Next, for the square root of y to the 11th, we're thinking of that index of 2. 2 goes into 11 5 times with a remainder of 1. So we would have y to the 5th and the square root of y to the 1st. And now we take the portions that aren't under a root and put them together at the front. 10 y to the 5th. We take the portions that are under a root and we put them together under one root. Square root of 2y. Looking at the cube root of 24, a to the 4th, b to the b to the 9th, we'll think of this as three separate parts at first. The number part, the a part, and the b part. For the cube root of 24, we'll simplify that by splitting it up into the cube root of 8 times the cube root of 3. And the cube root of 8 is 2. So the number part of our answer will be 2 cube root of 3. For the cube root of a to the 4th, 3 goes into 4 once with a remainder of 1. So we'll have a to the 1st times the cube root of a to the 1st. For the cube root of b to the 9th, 3 goes into 9 exactly 3 times, so we would have b to the 3rd. We take the portions that aren't under the root, 2a, b to the 3rd, and put those at the front. And then the portions that are under the root, the cube root of 3a, go together there.